All right, it's 11:30. Good morning, everyone. My name is Kyle Moore. I'm a senior engineer with Guidewire software, where my primary responsibility is I'm a committer and maintainer to the Gosu language at gosulang.org. I just want to say it's a tremendous honor and a privilege to be asked to speak at Gradle Summit this year, and thank all of you for spending your time with me this morning. So let's talk about my experience writing a compiler plugin or a language plugin for Gradle. So the agenda this morning is, and I have a lot of material, so I apologize if I talk fast and run through or skip over some things, but we'll talk about what is Gosu. I think it's fair to get a little bit of an overview because I doubt many of you are familiar with it. We'll talk about the key pieces of the Gradle API that are leveraged to build the compiler plugin, do a very quick demonstration. Then I'll also talk about two really important things at the end, which are the test kit API. If you heard Ben Mushko's talk yesterday, you would have heard a little bit about it, and I'll be able to point you to some good real-world examples as well. And then finally, some of the gotchas. Mostly writing the plugin went great, but there's a couple things you need to look out for. So, first of all, what is Gosu? Well, we already heard about another JVM language this morning with Kotlin. So, and we actually got a nice shout out from Dimitri, so that was great. So Gosu is a JVM language similar to Groovy and Scala. Traditionally, you don't have to compile Gosu. We can run it directly from source. And when our type system sees a class it needs, it checks the class loader for the bytes, they're not there, compiles it on the fly. Gosu began 13 years ago at Guidewire as part of our enterprise on-premise software product. And over the years, we've taken the time to extract it as a community release, and then eventually, I think 3 or 4 years ago, was open sourced under Apache. So, most of this being Gradle convention, gosh, that's awfully tiny type, but I'm assuming most of you are somewhat familiar with Groovy at least, so I thought I'd use that as a comparison for what Gosu does slightly similar or differently. So, Gosu is statically typed, but features type inference. So you kind of get the best of both worlds. You heard a lot about Kotlin this morning and static typing, so that's the one takeaway I want you to have. You can see here on line 1 of the Gosu example, we declare a variable. We don't need to say its type. The compiler will figure that out based on the argument passed in, but if I try to reassign it as something else on line 3, that's an error. Here's another comparison for lists, maps, and lambdas. So we operate similar to the way Groovy does. You can see down here on line 1 we use curly braces instead of square brackets for the list initializer, but like line 2 we use the each operation. Now, unlike Groovy, we do not have an implicit iterator, the it you're all familiar with using. When you declare something, you have to give the name to the parameter which the lambda is expecting, but you can see we can iterate over list of objects quite easily, and just like Groovy, it's way better, much more pleasant experience than Java. Finally, I forget what Dimitri called it this morning. I think it was extensions or something like that. Well, Gosu has something we call enhancements, which is a very similar concept. Now, I'm not an expert Groovy programmer, so if I got the left-hand side example wrong, please forgive me. But let's say I want to add a function or a method onto a class that I don't own, like java-lang integer. I wanted to add something called square it, so if it's Groovy, I have to use a mix-in, right, to declare what this functionality is going to do. In Gosu, I put that functionality in a separate class called an enhancement. You'll see here at the end of line 1 that this enhancement enhances type integer, and then on line 4, the keyword this refers to the type that I'm enhancing. Then in the snippet, the code example below, you'll see that whenever I have a reference to an integer, that method automatically appears in the domain. This is my last Gosu example. I could go on for an hour about this, about our our new support for structural typing, our excellent generics, full Java interoperability, but we're here to talk about Gradle. So if there are questions afterward, I'm happy to answer that too. So why write a language plugin? Well, I mentioned that historically Gosu was dynamically compiled at runtime, but there's so many tools out there, whether it's the Maven, Surefire plugin, or running tests in Gradle, that are basically hard-coded to look for a .class file on disk, and traditionally we didn't have that. So we're missing out on a lot of kind of free tooling support you get in the Java community, Java ecosystem, I'll say. Secondly, the timing was just kind of right in that my employer Guidewire was migrating its Franken build, which was a mix of Maven, Ant, a homegrown tool, and shell scripts, everything, to Gradle. So the timing was right to leverage the excellent extensibility of Gradle to add the feature we needed. Excuse me. Finally, Gradle provides really good examples. They're bundled with Gradle, but you've got how to take a non-Java JVM-based language like Scala and Groovy. You've got great examples right there in the open source code to check out. And finally, the plugin portal was another really great way to distribute this. So all the pieces are there in place. Okay, before I jump into all the pieces of the Gradle API I had to touch, or which interfaces I need to implement, there's one kind of prerequisite, and I'll come to later why I had to do this. But you need to have an Ant task in your language, which Gradle's compile task is going to delegate work to. There are other possible ways to do this, but that's based on something very recent that happened with Gradle, and at the time I started this work, Ant was the best way to go. So, what happens, what happens when you apply? What is the Groovy or the Scala plugin for Gradle? Well, there are actually two different plugins. There's a base plugin, which you never even know about. It's under the covers completely, and the Scala plugin, Groovy plugin, as you would expect. There's a little code snippet down here, which is, sorry, a little hard to read, but this is an example of what happens when you apply the Groovy plugin. Well, something interesting happens. The first thing, it applies the matching Groovy base plugin. Secondly, and this is interesting, it applies the Java plugin. And guess what? The Java plugin goes and applies its own base plugin. And then finally, it'll do some additional setup, like creating default task types, creating a Java doc and a Groovy doc, steps, things like that. So, mocking that, or modeling on that structure, we start off with the Gosu base plugin. So the interesting things that we'll do is it registers an extension to the DSL. We have a method to configure all the default compile settings, the things that things that are convention that you shouldn't have to configure on every build. There's a step where it infers the runtime component based on your base library, and I'll talk about that on the next slide. And finally, setting more of the source directory defaults, right? Like if you have a Scala project, it's going to be source main Scala, source test Scala. Well, we do the same thing: source main Gosu, source test Gosu. And finally, there's a Gosu doc task, which I won't go into today because documentation is no fun. So I mentioned inferring the runtime component. What does this mean? So depending on the language, it may use a fat jar, which includes the compiler logic as well as the runtime logic, or as it is with Gosu, those are broken out into separate libraries. So when we infer the runtime component when the plugin is applied, the first thing we do is look at the class path and check that at least the Gosu core API jar is available. Based on the presence of that jar, Gradle provides a version number class, which it has a regular expression which is going to strip out just the version number. So I know I'm using Gosu 1.12. Okay, now I need to go get the runtime component which is the name of that artifact is hard coded because we know what it's always going to be, but the version number is inferred from the class path of the project. Groovy Scala do the same thing. The logic in the Groovy plugin is it looks for the Groovy all jar, and if it's there, you're done because that's a fat jar with everything. If it's not there, you go get the Groovy Ant, which has the Ant compiler I mentioned. Scala is a similar case. You have to declare a Scala library jar if you want to use a Scala plugin, and at runtime, if you don't have the Scala compiler explicitly on your class path, it'll go out and grab it. So it's interesting that the dependencies of the project at execution time are not necessarily going to be what's in your build script. Now, the source set interface. So this is This is where we get into helping the compile tasks look on disk and figure out what files they need to include. The default implementation of the source set interface configures a source directory set instance. What is a source directory set? Well, it has a property called getFilter, which returns a pattern filterable. What is a pattern filterable? Well, this is where you set include and exclude ant file masks to determine what files you want to include or not. This is interesting because when I've done similar work in the Maven world, it's hard-coded that you have one file extension. And actually, Groovy was a great inspiration for how you're going to get over that barrier. Groovy, just like Gosu, has more than one potential extension that a source file could have. So, the flexibility of the API here in Gradle is excellent because I can include all 4 of these different patterns, which are the legitimate inputs to the Gosu compiler. Now, there's a note here about a confusing naming convention that you'll see when you work with Groovy or Scala plugins. There's something called, for example, getGroovy from the source set, which is going to, based on your file pattern, it's going to return all of, getGroovy is the name of the method, remember. This gives you all the Java and Groovy files in the project. There's another method called getAllGroovy, which returns just the Groovy. So it's a bit confusing, but Gosu follows the convention, but that's all I'll say about that. So. Okay, so now the most important thing, the task definition, which actually is going to do the compilation. So this is the Gosu compile task. It extends Gradle's abstract compile, which is itself an extension of a source task. This is important because a source task has your defined input files, right? Which are all when we talk about task up-to-date checking, things like that, that's how we get all this behavior for free when we implement this abstract, or we extend this abstract class. It has a single method called compile, we just need to implement. And there's a couple interesting fields that it exposes in the build script DSL. That is the compile options, and then you have a language-specific compile options you should be implementing as well. So what are compile options? Well, these are pretty compiler agnostic, language agnostic attributes you'd normally be setting on a compile process. For example, fail on error, true or false. List files, which is another Boolean, whether you want to verbosely list every single file that you read in the source set and you're going to then pass to the compiler. A couple other options like debug or fork, which are also Boolean properties. They have another object, which is like a bean, within a bean, which is holding additional properties. Like when you debug, you want to give specific maybe JVM arguments or fork options. This is when you're going to do out-of-process compilation. You might want to give extra memory requirement to that spawned JVM process. This is where you can set those types of properties. Now the language-specific Gosu compile options, well, Gosu hasn't had a command line compiler or really anything that was used outside of its own ecosystem. So we're pretty light in this regard. The only option we set is whether to use ant or not. Now, in the current implementation, ant's the only option, so this defaults to true. There's no need to set it, but for reasons I'll go into later, there are other options that will expand this options class in the future. Now, one critical thing to note here, though, is you need to implement a method called exclude from ant properties. That's because we're going to talk about something in a minute called the isolated ant builder. This is going to take all of the options which the build script sets, bundle them up, dynamically generate an ant task, and execute it. Certain things like is use ant or not, well, ant doesn't need to know about that. So we need to, this method is going to filter class error, specific properties we don't need from the ant execution. All right, so let's back up a second and look at the high-level overview of what's actually happening when we apply a language plugin to a project. I've mentioned the source sets and directory sets now, and it's very difficult to do a class execution diagram or anything like that, but I'll do my best. So on the left third of the page is what happens when you apply the language plugin. Well, it applies its own base plugin as well as the Java plugin. Java plugin applies Java base and a couple more nested underneath that. The Java plugin defines two source sets. That's your typical things you see, the main and the test, while the Java base plugin as well as the Gosu-based plugin, define its own source directory sets. That's the get Gosu or get Java, get Groovy, things like that. That's the source directory set it returns. Now, the plugin will combine the source sets and source directory sets to give you your default locations to look up files. So that's where the source main Java, source main Gosu, source test, etc. That's where your defaults all come into play. Finally, the Gosu plugin defines the compile Gosu and compile test Gosu tasks, which in fact are dependent on their equivalents in the Java world. So I guess the takeaway from this is the pattern that I've seen for language plugin development in Gradle is everything depends on Java, and you're basically piggybacking on top of a lot of existing functionality. This is good though, because as a language plugin writer, it saves you a lot of work. You don't need to reinvent the wheel entirely. Okay, so we've applied a plugin to our project. Now what happens at runtime? Well, as you can imagine, the compile Gosu, compile test Gosu tasks are both instances of the Gosu compile task we talked about earlier, which implements abstract compile. When the build script is analyzed, a compiler factory returns an instance of the appropriate compiler. Now, again, we're only using Ant, so that's the only option that's going to be returned. But if you look at the implementations for Scala or Groovy, based on the options we specify in the compile options or the language-specific compile options, you might get back a in-process compiler or an out-of-process compiler. And those implementations are all going to vary depending on the language. Yes? It's a good question. Gosu is a full interop language with Java. If you're doing a non-JVM-based language, sorry, I should repeat the question. The question was, is there a need to include the Java plugin, or do I only need that because we interoperate with Java? So my answer would be, if you're using a non-JVM-based language, then no, it probably makes sense to write a little bit more from scratch and not depend on Java. However, when you do look at the implementation of the Java plugin, that'll give you a better idea of the groundwork that needs to be laid. So we talked about at runtime, the compiler factory is going to return, instantiate, and give me an instance of the compiler that's going to receive, that's going to do the work for me. So in this case, it's always going to be an Ant Gosu compiler. Now this is the last step on the Gradle side of things before it throws work over the wall or delegates to the Ant compiler. So what happens? There's this cool class called Isolated Ant Builder. And even though maybe there's a way, but it was frustrating that this is basically building a build.xml like you would do in Ant, but it's doing it on the fly. And at debugging time, it's a lot of fun because you won't be able to see what it contains. You just build it in a closure and kind of throw it at the wall and see what sticks. Basically, there's an object called a compile spec, which is a bean which holds your compile options, language-specific compile options, anything else you would have configured in the closure or in the build script. The class path also is inherited from your project's compile and test compile configurations. And then finally, we build this kind of dynamic Ant task, and as I said, throw it over the wall. Based on the success or failure received, the return value received from Ant, then that's what the compiler is going to report to its owning task, whether it's compile Java or compile Gosu or whatever. So, if hopefully everyone is not completely confused at this point, so let me show you a simple example in code of what the simplest possible application of the Gosu plugin would look like. So lines 1 through 3, you see we're using the new plugins DSL. The Gosu plugin is published to the plugin portal, so we don't need to set a repository or anything for it. It just automatically goes to JCenter and finds it. For the project dependencies, though, like the Gosu library or JUnit, I've specified repositories on lines 5 through 7. And then finally, we have the dependencies. I mentioned the runtime library inference. Well, Inside the Gosu plugin, there's code which checks that the project class path at a minimum contains the Gosu Core API jar you see on line 11. So if you're implementing a language and you have a bare minimum requirement of what libraries need to be there, you're able to do that in your plugin implementation. And if you try and apply the plugin, you're missing this library, you try to run it, you'll get a nice helpful error message saying, you need at least this library, go and apply it. I also talked about inferring the runtime component. So I used Gosu version 1.13.4, so it's going to go out to Maven Central, look for our runtime jar of the same version, and download it. So this is a bit of an eye chart, I apologize, but I mentioned all of those defaults that were set in the objects, like the source directory set and the compile options. So hopefully your take-home slides will be easier to read this, but this is that basic build script from the previous slide. But if I went and explicitly listed all the default values which are set by the plugin when you apply it. So when you look at all this and you think you can abstract that into just a little three-liner in the plugin's closure, that's pretty cool. You can see that the default source main Gosu directory is set. You can see its filters which are applied. Similar thing happens for the test world. And then finally for the two tasks which are created and added to the project by the plugin, compile Gosu, compile test Gosu, you'll see what's their default class path, where do they get their jars from, and then also they explicitly set their include and exclude properties based on what's actually coming out of the source sets. So that's why the compile task extending the source task, which is much more abstract, but makes it very easy for us to decide which files to include or not. If you wanted to exclude like some certain package, has problems or it's a work in progress, you don't want to compile it, then you would configure. You don't need all of this configuration. You would normally do in any other Java project. So kind of an overarching theme I would also say here is I tried to stick as close to the implementation as the other JVM language plugins, including Java, as possible. So even if you don't know a thing about Gosu, but you've configured a build.gradle file before, you should be able to get up and running with this as long as you know which library needs to apply which. On the documentation on the plugin portal, I made sure to put in, like at a minimum, include this one line for your compile dependency. Okay, I'm going to go into a quick demonstration in a moment. Are there any questions before I jump into that? Yes, Baron.
Is this actually how you started when you did the plugin explicitly in this, or did you just jump right in?
I just jumped right in, just both feet, blindfolded, fearing nothing. Okay, bear with me a moment. We're not mirroring. Okay, this looks visible. So first thing I want to do is just give you an idea of the structure. So we're just going to look in the. If I did the whole project, that'd be we'd see the whole Gradle wrapper and everything else. So I don't want to show you this, but here's an example of what we're going to demonstrate compiling. So I have a source main Gosu, a source test Gosu, an example package, and then two classes in the main, and then one test. So this will look just like you were compiling or executing a simple Java project, except you'll notice that we see the compile Gosu task shows up, as well as compile test Gosu. And I'll show what this project actually does. I appreciate your patience. We've all seen a lot of Hello World examples this week, I think, so it's pretty close. So where's the test? Is it the HTML build reports? There we go. Okay, so I had one test which executed here. It was in the example package called foo test, and it passed, and it gave us some output. So just like you'd be expecting with a Java project or Groovy or whatever, Java executes, then Gosu executes. It didn't find anything. There's no source for Java, so those tasks are inherently up to date. And same thing happens for compile Gosu, compile test Gosu. It's not very legible. Let me go back to the editor. So this is the same build script in IntelliJ that I showed earlier. That's what we just ran. And I don't think anyone cares about the content of the test, but it's just a simple JUnit test, which makes an object, prints it out, asserts that something happened. So while I'm looking at the editor, one cool thing I'm going to take a risk here if I actually show this, because our editor plugin is a little bit weak, but you'll notice here that source main Gosu, source test Gosu are highlighted so that the IDE recognizes them as blue for a source root and green for a test root. If I go back to my build script and I remove the application of my language plugin and refresh the project, remember that this was also applying the Java plugin. So we're going to go back to like a very, in fact, is this going to blow up? I'm not sure we can have a compile dependency if we don't have a JVM-based language. Yeah. So I need to get rid of this as well. Oops. Trackpad. Okay, so if you were starting from, you did like a Gradle init, and you're starting from just a bare bones project, you have almost nothing here. Now I'm going to go through and you'll notice that source main Gosu folder, source test Gosu, now they're just normal folders somewhere in the project. They don't have any meaning. But now once I apply my plugin, this is pretty cool IDE integration magic you just get for free when you implement a language plugin. So now that I've refreshed the project, you'll see those morphed back into recognized source and test roots, which is pretty cool. Okay, oops. I'm in the wrong place. I don't want to mirror anymore. There we go. Okay, now a couple of interesting things I want to talk about at the end here. One is testing. A unique, well, first of all, this will be a slight bit of overlap with Ben Mushko's talk yesterday, but when you're testing your plugin implementation, there's this really cool library called Gradle Test Kit. Definitely apply it, take advantage of it, use it. Now, supposedly there's a new plugin which came out in 2.13, I think, which supersedes this, but it's, basically it's a way to remove a little bit of boilerplate code. It's doing something very similar. And combined, when you take this Gradle test runner, which is provided by the Gradle Test Kit API, and you combine that with Spock tests, it's very, very powerful for simulating exactly what your plugin is going to do. And this would apply, I guess, to any Gradle plugin, not just to a language-based plugin. The only shortcoming I'd mention is that it's difficult to get the class path of your plugin onto the class path of the Gradle runner. Ben talked about this yesterday. I'll just leave it here in the slide, but basically you need to dump out the outputs of compiling your plugin as well as its own class path into a file. Read that file back in later when you're testing your plugin, and then you'll actually make sure that it happens. But the really important thing I want to leave you with today is when testing a plugin, especially a language plugin like this, I have a problem that is inherently not present in the official Gradle distribution itself. So Groovy and Scala are bundled with Gradle 2.11, 2.12, 2.2, right? They're just there automatically, and they version along with Gradle itself. So I have this major problem now, which is, oh, I built this with Gradle 2.3 in the beginning, and now I'm using 2.9, but what if somebody's using Gradle 2.8 or 2.6? How do we know that this plugin is actually going to work for them or not? And there's a couple other, there's definitely some speed bumps I encountered along the way. For example, there's no way around it. I had to leverage a lot of internal APIs or internal package of Gradle. There's nothing to prevent me from using them, but just based on the package name, including the word internal, I know I'm playing with a little bit of fire. And sometimes method signatures, things like that, change between versions. So there's a relatively newer, maybe this is from 2.9 or later, a new thing called with Gradle version, which is a property of the Gradle runner. It's a builder, basically. When you're building the Gradle runner, you can say, I explicitly want to run with this version. So, sorry, another eye chart again, but based on the unroll annotation, which Spock provides, and setting the with Gradle version property on your test class, you can iterate over a list. So I defined every Gradle version from 2.3 all the way up through 2.12, and for every functional test I write, I execute it 7 or 8 times, or with whatever range of Gradle versions that is. And not surprisingly, certain APIs I used when I instantiate the compiler, like in I think Gradle 2.5 or 2.6, they broke. So another thing I did was I built a map of, let's say it was a map of a string and a Boolean, right? Whether I expected the test to pass or not. Because there's a couple of cases where I know it's just going to be broken. So the string would be like the Gradle version number, and then whether I expect it to pass. So that's something I suggest anyone consider for writing a plugin, especially if you know it's going to be, yes?
When you also have libraries such as Gosu that have different versions, do you have any tips on testing the full Gradle version and Gosu version?
Yep. That's a good question. The question is, when you're testing a library which itself has multiple versions, do I have any advice or experience versioning that as well? Well, no, I don't, because I own the API of Gosu, and it's very stable, and there's only two classes that I'm referencing. However, there's no reason why you couldn't do the same thing here. It would just be like a two-dimensional matrix, right? Depending how many versions that library has, we could be talking about a lot of tests. And one problem I did have with this is we use Circle CI to do our continuous integration. And it's a great service, it's free. They do have pretty stringent memory requirements, and I believe you're going to get a separate instance of a Gradle daemon for each version you're testing iteratively like this. So it didn't take long by running 6 or 7 different versions that the container said, your project's using more than 1 gigabyte of memory. And this Circle CI came from the Ruby world, so they're like, there's no way a project should need more than 1 gigabyte of memory. Something must be wrong. Well, sorry guys. So yes, you can do that. I've had to include some logic. So one nice thing is like Travis or Circle or other platforms is usually they'll set an environment variable called CI, and maybe the value is true. Doesn't matter, but it's pretty easy to inspect whether that exists or not. So if I'm testing it locally, I usually go through the full entire suite on my Linux box. When I publish it out on the web, it's usually in that container. It's just usually running on the latest version. So I haven't done, that was the long answer to your question. The short answer is I haven't done it, but using the same practice, you could definitely do it. Oh, sorry. I'll expand on that just a little bit more. I'll back up a couple slides where I showed something Ben mentioned yesterday. Oops, this one. Create ClassPath manifest. This is where I got the outputs of compiling the plugin as well as the class path that the plugin needed to be compiled. That's what I give to the Gradle runner so it can test the plugin. Using a very similar logic, and that Gradle class called version, or maybe it's a Groovy class, version number, getting the version value of the current version of Gosu I'm testing, you could also make like an array or a list of numbers and also pass that in. When you generate your build script dynamically, that is passed to the Gradle runner. I hope that makes any sense. But that's how you would iteratively, dynamically swap out So I don't hard code the Gosu version anywhere in my plugin. Instead, it's in like the Gradle.properties at the root of my project. So it's easy to go change. I don't have to hunt in any boilerplate code where I'm explicitly, setting a value there. Okay, we want to leave a couple minutes at the end for questions, so I'll mention a couple other gotchas and then leave you with a little bit more information about Gosu and my contact info and things like that. So I mentioned before, there's pretty extensive use of internal package APIs when I'm doing this. It's, of course, totally undesirable, but the state of things today, it's unavoidable. Now that I heard what Cedric had to say yesterday about Jigsaw and Java 9, I'm kind of scared out of my mind right now about how we're going to stay compatible in the future, but I look forward to continued collaboration with the Gradle core devs on this. But thankfully, using the with Gradle version method on the Gradle runner, we can anticipate these issues before they come out. There's no reason why today I couldn't go into my test superclass, add Gradle 3.0 RC2 or milestone 2, whatever it is, and I'm expecting that's going to fail, but we'll see exactly how, and you can anticipate those problems before they actually come up, and you need to do the upgrade for real. Finally, thank you to Skulk here, who gave me some good advice about using reflection to look at some of these changing APIs, like things, I think it was a file tree constructor or something like that changed in Gradle 2.12. And it went from a 2-arg constructor to a 3-arg constructor. So using reflection, you can look at this class you expect to be there, get its arguments, and then do a little bit of branching logic. Better to avoid that, but when you're not bundling a plugin with Gradle itself, there's really, nothing you can do. And then finally, the big thing that I'm looking forward to is forked compilation or out-of-process compilation. Doing some experimental work on my own, I've shown that this can be an enormous performance benefit over just using Ant. And we did a little toy Hello World project here. That's no big deal. But at Guidewire, where I work, we have an enormous monolith repository with, I think, 200 sub-projects, and compilation can take anywhere from 14 to 30 minutes and use 12 to 14 gigabytes of memory. If I'm able to leverage forking compilation, I can take the time and the memory usage down by about half. So this led me to filing a pull request to include Gosu with Gradle itself. Unfortunately, it was not accepted, but that's okay. And it's led us to something I think it's going to apply to many more plugins than mine, which is looking forward to Gradle 3, the Jigsaw internal plugin, or internal package protection. It's this issue called Gradle 3.4.2.7, which is how can we expose this out-of-process daemon compiler functionality to third-party plugin authors. So again, I look forward to working with Pepper, the community team, and everyone else to hopefully make this into a reality soon. One last thing I'd say is Gosu does not use joint compilation, and for a minute I was kind of having trouble figuring out what that meant. Other Scala and Groovy refers to joint compilation as when you put Java and Scala or Groovy sources under source main Groovy, source main Scala. You're not actually separating them. Now, why would you want to do that? Well, remember that they're both writing to the build classes or build test classes directory. If you compile Java first and put it into build classes, and then you run another compile task looking at the same output, well, they're inherently going to be out of date, and they're going to rerun, possibly unnecessarily, every time. Now, this is something new that's come up, since we started compiling Gosu, and talking to the Kotlin guys earlier, I think they're running into the same problem, so we'll figure out how we want to do this. There's certainly ways in the DSL configuration we could get around it, but if you are looking at, say, my plugin implementation versus Groovy or Scala, that is one difference you'll notice. So we have full interop with Java, but we don't compile Java. And this kind of is the way we grew organically out of Guidewire software, where the typical pattern is we'd have a compiled Java interface implemented by a Gosu class. But since we didn't compile the Gosu class when we ship our product to our customer, the implementation of how they satisfy that interface contract was kind of left to the customer. So that's kind of why we don't do the joint compilation, but that's a possibility for the future. In your slides, you should have some examples. So the source of the plugin, this is a clickable link, even in the PDF, I checked, thank goodness, to a GitHub repo. And then the first project I ran was example Gradle simple. That's the first link you'll see here. Example Gradle hybrid is similar, but it compiles Java first, like the interface example I just mentioned. It will do Java first, and then the Gosu compilation includes it on its class path. If you're curious to learn more about Gosu, here's a link to our blog. Finally, the source of the Gosu Link project. We're always welcoming contributions, so please feel free to check it out. And did anyone know there's a Java magazine? Until it came out, I didn't know. It's actually run by Oracle. And in the January-February issue this year, Scott McKinney, my mentor, who's the founder of Gosu and the architect, published a really good article. So if you liked the Kotlin presentation this morning, you want to kind of see it's a really good article, very simple and some very concise and pragmatic, good syntax examples. I definitely recommend checking that out. Flash warning, they said they're converting all their articles to PDF, but for now it opens like a weird Flash-based, like magazine reader, like catalogs type app. So be careful when you click on it. Finally, what's next? Well, I'm still kind of stuck on Gradle 2.9. I've been doing some experimental branches to upgrade to a new, more current version of Gradle. And why am I so far behind? Well, it's just, have a day job and other responsibilities. And our most current release is on Gradle 2.9, so that's just why I've been kind of mired down in that. Any plugin, supposedly, that compiles down to JVM compatible bytecode, it doesn't matter what language you write it in, apparently. So another fun thing to do in the future, I think, would be convert my implementation from Java to Gosu itself. I think that'd be a pretty cool thing to do. I mentioned joint compilation is something we're missing. This could be a big one. I think there's a quick and dirty way to do it, and then there's a way where you have to write a Java parser. So we'll see how that goes. And then finally, thank you. Someone asked about the software model earlier. I do know it works from the pull request that I've created, but whether I want to include that in the open source yet, I know at Guidewire we're probably going to be sticking with the, I don't want to say legacy, but the current DSL structure for a while. So one last thing is we're all big fans of Adventure Time on the Gosu team. So in conclusion, thank you all for attending. Again, it's been wonderful to share my time with you at the summit and make a lot of new friends this week. So if there's any other questions, I'm happy to answer them. So thank you.